Hey, what's up? The most powerful skill for those who use Vellum is to be able to affect simulations using animated attributes. This is the reality stone of the Vellum universe, allowing you to do whatever you want with the available geometry. So I made this video to be the reference I wish I had. In this example, the torus is rotating before it gets to the Vellum solver, and after it, it's not. Because by default, the Vellum solver takes the geometry as it is in the first frame and ignores any animation that comes afterwards. It means that if you animate any property, it will always use the same value from the first frame. And if we scale by an attribute which is animated, it will use the attribute's value from the first frame. The only animated thing in the SOPs context that the Vellum solver reads every frame is the position and orientation of the pin geometries when we check the match animation box. It can be used to pin some points or to match the geometry deformation using the pin to target constraint, for example. And this pin group also can't be animated. Very limiting, but Vellum has another way to animate properties. When you dive into DOPs and add a Vellum constraint properties, you can animate properties here in this node. Select the constraint group you want to edit, in my case band, and as soon as you enable an attribute, it will override whatever your setup was in SOPs for this attribute. In this example, I increase the band stiffness over time. If you use Vex expression and select pass-through, you can either modify or override these attributes using Vex. But what if you want to use an attribute from SOPs to drive this animation, like a map, a falloff, or a mask? This is the reality stone you need, and I will explain it using these soda cans. Let's make them go from chaos to order while inflating along the way using maps. But first, I'll explain quickly the setup. You can skip this or check the project file. I imported this can model and cloned some instances of it in this specific layout using copy node set to pack an instance. Then I used this free Frustum HDA from Cipos Attila to select only the cans that the camera will see. There's a link to all custom HDAs I used in the description. Then I gave these instances random rows and angles using my random transforms HDA. Notice that this node is writing an orient attribute, but to see our packed geos in the right orientation, I used a copy to points and created new instances of the cans. Before the copy to points, I animated a blend from this chaotic position to the final ordered layout, and created an orient attribute to blend with the first input using my custom orient node. Fast forward, now that the animation is working, I created a huge grid for the ground, animated a linear falloff passing through the cans, used a point VOP to create a wave distortion on it, copied and pasted both nodes inside my can layout to move the cans with the wave, and unpacked them. Then I used a convex hole, an edge cusp, and a remesh to make the mesh of these cans appropriate for Vellum, fusing points at the end, and wired a copy of the same layout and animation nodes we just created to this new mesh. So now we have the same animation, but with a proper mesh for Vellum. From here we go to the Vellum setup. I need a configure balloon, which gives me cloth and pressure constraints, a pin to target set to soft and match animation, so that they can follow the position and rotation of my animated cans, a shape match to make them rigid at the end, and a Vellum solver with 4 substeps and velocity damping. I wired my animated grid as a collision geometry and used this default thickness to place all my cans 0.01 units above the ground using a match size in both layouts. We went fast. Now, the question of the video is how to use animated attributes to drive Vellum simulations. But before this question comes another. What maps will I use to influence the Vellum simulation? Let's answer that. On Patreon, you can watch this full video and download all the files I used, including my custom HDAs. There, you'll learn how to automate this process, reducing it to 2 clicks, and I'm gonna tell my easy method for dealing with complex effects that may need many falloffs or maps like these cans. You can use the link below to watch it. See you there.